Hello everyone, welcome to my channel. Keep exploring. In this video, we are going to learn how to represent irrational numbers on a number line from the chapter Number Systems, class 9. So let's start. So we'll start with visualizing root 2. For that, we will need Pythagoras property. For this, we'll consider a right angle triangle with a perpendicular, a base and a hypotenuse. Pythagoras property says that h equals to root over of p squared plus b squared, where p is the perpendicular and b is the base. Suppose if we consider perpendicular as 1 unit and base as 1 unit, both perpendicular and base as 1 unit. Now using the property, what we see that h is equals to root over of 2. So this says that if perpendicular and base are of 1 unit each, then surely hypotenuse will be of root 2 units. In this way, we can visualize the length of root 2. Now, we will be using the same concept and start representing different irrational numbers on the number line. To start with, root 2. So here is the calculation we have. Root 2 can be written as 1 plus 1, root over of 1 plus 1, that the number 2 has been written as the sum of two square numbers. So 1 is a square number, so both 1, so 1 can be written as 1 square here also. So 1 will be taken as the perpendicular, another one will be taken as the base. So we get p square plus b square. Let's see. First, we will draw a line using a ruler, mark a point. Then we need base as 1 unit. So using a pair of compasses, we will mark a point OA. So that will be taken as 1 unit. So here point to be noted is 1 unit can be anything. It can be of any radius. It can be of 1 cm, 2 cm, 5 cm, anything. So it should be 1 unit, and that 1 unit will be using over all the constructions. Now see. So we need perpendicular also as 1 unit. So for that, first we will need to draw a perpendicular line from A. Now we know that base is 1 unit, so perpendicular also has to be 1 unit there. Then we'll measure OA and mark it the same radius and point B. Mark it as point B. So OA and AB both will be of 1 unit. Then we'll join O to B and get our hypotenuse. So here in our figure, OA is 1 unit, AB is also 1 unit. Now OB will be our hypotenuse. So using the Pythagoras property, we say that OB is nothing but root over of OA squared and AB squared. 1 squared plus 1 squared, we get 1 plus 1, that is root 2. So OB is of length root 2 units now. But the question is, we have to represent it on a number line. So this is our number line. So you have to represent OB, that is root 2, on this number line. So for that, we will measure OB using a pair of compasses and plot the same length, taking the same radius, and plot it on the number line and mark it as C. So this point will represent root 2 on the number line. So AC, OC and OB both are same length, so we get as root 2 units. So the point C will represent root 2. Next, root 3. Now we see that for any construction we are taking square numbers, but here it is not possible because we add any two square numbers, we are never going to get 3. So for that, what we are doing? One of them must be a square number. So we know that 1 is a square number. So 1 plus 2 gives 3. Now 2 can be written as root 2 whole square. So root 2 will be taken as the base and 1 will be taken as the perpendicular. So first our work is to construct root 2 on the number line. So for that, the previous construction will follow. We will take base as 1 unit and perpendicular as also 1 unit. So 1 upon 1. So this will be easy for us. 1 upon 1. When we take, we get root 2. So whatever the base we take, we have to consider the square of the base. That is, if the base is 1 unit, so I will consider 1 square. If the perpendicular is 1 unit, we will consider 1 square. So 1 square plus 1 square, we get 2. So the hypotenuse becomes root over of 2. Now we will plot this on the number line. So this is our point root 2. So we have got our base. root 2 is ready. Now perpendicular should be also 1 unit. So we'll place the protector and draw a perpendicular line from the point root 2 and take the measure of 1 unit and mark it on the perpendicular. So this is of 1 unit. So our new base is of root 2 units and new perpendicular is of 1 unit. So using the Pythagoras property, as you can see here, the hypotenuse will be surely root 3 as per the calculation. So now root 3, we have to plot it on the number line. Taking the radius, we will plot it on the number line. As you can see here, already we have discussed how to do it while we are doing the root 2. The same concept, using a compasses, take the radius root 3 and plot it on the number line. So and mark it on the number line. So this will represent a point root 3. So this total length will be of root 3 units. Next, root 5. So let's see the calculation. Now root 5 can be easily written as 4 plus 1, and here we see that both 4 and 1 are square numbers. So there is no issues. This one will be taken as the base and this will be taken as the perpendicular. So first, using a ruler, we will mark 2 units. So this is 1 unit, another unit. So total it becomes 2 units. You have to take care that we take the same measurement. So we have to take the same radius and take 2 units. So OA will be of 2 units. So base is ready. Now we need perpendicular. So from the point A, we will draw a perpendicular line and mark 1 unit using a pair of compasses. So you take the same unit, same radius and mark a point B. So here we say that AB is of 1 unit. Now according to the property Pythagoras, it says that when join the hypotenuse will be surely OA square plus AB square root over. So we get root over of 5. So OB, the hypotenuse is root 5. Now root 5 we need to plot it on the number line. We'll measure OB and plot it on the number line. You can see here. So here we see that OB and OC both are of the same length, same radius. So OB is root 5. So OC will be also root 5. So point C represents root 5 on the number line. Next, root 7 or root 6. Now root 6, let's see our calculation. Root 6 can be written, it cannot be a sum of two square numbers. So we have considered the nearest square number is 4. The nearest square number less than 6 is 4. So we have added 4 and 2, we get 6. So 2 can be written as root 2 whole square plus 4 has been written as 2 square. So here it is clear, this will be taken as the base and 2 will be taken as the perpendicular. Always remember that the irrational numbers will be taken as the base and the rational numbers will be taken as the perpendicular. Let's start the construction now. So base we need root 2. So we already have seen how to construct root 2. Now after plotting root 2 on the number line, we see that the perpendicular is also 2 units. So first we will draw a perpendicular line on root 2 and come just measure 1 unit and take 2 units on the number line. You can see here we have taken 2 units on the perpendicular line. So root 2 on the number line, this is root 2, base is root 2 and perpendicular is 2. So according to the Pythagoras property calculation, root 2 whole square is 2, 2 square is 4, so 2 plus 4 we get 6. So our hypotenuse will be of root 6. Now we need to plot it on the number line. The same concept, we'll measure that root 6 using pair of compasses and plot it on the number line. So this will represent root 6. So this is one calculation. We can do this in other way. In the previous section we have seen that how to construct root 5. So once we get root 5, we can just construct 1 unit on root 5 and we'll get root 6. This is also can be done. Once you construct root 5, upon root 5 if you construct 1 unit as a perpendicular, you will surely get root 6. This also can be done. Choice is ours. Next, root 7. The same thing. Root 6 upon root 1 will be root 7. This can be done, or else let's see the calculation. The nearest square number of 7 is 4. The nearest square number is 4. So 4 plus 3 is 7. So here we say that 3 is written as root 3 square and 4 is written as 2 square. So as we discussed, root 3 will be taken as the base, 2 will be taken as the perpendicular. So first we'll draw root 3. Already we have seen previously how to draw root 3. So to draw root 3, first we need root 2. So root 2 upon 1. Root 2 upon 1 will give us root 3. Now after getting root 3, we need 2 units as perpendicular. As you can see, already we have got root 3 at the base. We need now perpendicular as 2 units. So for that, we'll draw a perpendicular and mark 2 units on the perpendicular. So see here. So root 3 upon 2. Root 3 whole square is 3. 2 square is 4. So 3 plus 4, we get 7. You can see here. Root 3 whole square is 3. 2 square is 4. 3 plus 4 gives us 7. That's our calculation. We get the hypotenuse as root 7. After getting the hypotenuse, we'll just plot it on the number line and mark it. So that will give us root 7. This is a way, or else we can draw root 5, root 6 and then root 7 also. Root 5 upon 1 will give us root 6. Root 6 upon 1 will give us root 7. In that way also we can draw it. Next, root 8. So root 8 can be simply written as 4 plus 4 because both 4 and 4 are square numbers. So if you take the base as 2 units and the perpendicular as 2 units, we'll get easily root 8 and plot it on the number line. So this can be done. In other way, let's see how it can be done. Now 8 can be written as 2 into 2 into 2 prime factorized. Now from this, 2 and 2 forms a pair. So it will come out. So we get 2 root 2. So this is 2 square. So 2 square square root becomes 2. So 2 root 2. Now let's see how we represent 2 root 2 on this number line. So for that, 2 root 2. What do you mean by 2 root 2? This is nothing but 2 times root 2. 2 times root 2. So first we will do 1 time root 2. We know already the construction, how to draw root 2. Now, once we get root 2, 1 upon 1, root 2 we have got. Now, we need 2 times root 2. So here, we will measure root 2 one time and take the same measurement from root 2. We will draw another root 2 and we get 2 root 2. Let's repeat this. Root 2, again root 2, so we get 2 root 2 and we see that 2 root 2 is nothing but root 8. That's the same thing. 2 root 2 is same as root 8. The last construction, root 10 on a number line. Let's see. 10 can be written as 9 plus 1. So 9 is a square number, 1 is also a square number. 9 is the square of 3 and 1 is the square of 1. So 3 will be taken as the base and 1 will be taken as the perpendicular. So let's draw 3 units on the base. So we have taken 3 units, equal units of 3. Then upon 3, we will construct 1 unit. Take a perpendicular and measure 1 unit. So this becomes 3 units upon 1 unit. So from the calculation, we have got 3, we have got 1. So b square and p square. So 3 square becomes 9, 1 square becomes 1. So 9 plus 1 will give us 10. So our hypotenuse is root over 10. After getting the hypotenuse, we need to just plot it on the number line and get our required point. So this will be root 10. So here we see that there are many ways of constructing on a number line. It only depends which concept we are using. You can choose the nearest square numbers and do it, or one by one we can see. As we know that once we get root 2, if we construct root 2 upon 1, we get root 3. Root 3 upon 1 will get root 4. Root 4 upon 1 will get root 5. Root 5 upon 1 will get root 6 and so on. So in this way also can be done. So that's it for today. Thank you.